My name is Harshawn. This is my Lab 3 bar magnets presentation. So the introduction, the purpose was to observe and better understand magnetic fields through the visual representation and use the dependence of magnetic fields in the Biot-Savart law to find the magnetic moment of a bar magnet. So the fundamentals were using a bar magnet to model the magnetic dipole, the Biot-Savart equation, and the distance dependent formula for a bar magnet. And these are my results right here. Now, the assumption was that we assume the bar magnet acted as a magnetic dipole in order to apply the Sarvari law. So the experiment was so the experiment had systems and surroundings. So the system was a bar magnet, and the surrounding was everything else. Initial conditions were the bar magnet and the magnetometer on the iPhone or on phone. And the details were the first location of the magnetometer was on the phone and was pinpointed by sliding the phone perpendicularly to the ruler with the bar magnet on one end of the ruler. This was in order to see which position the phone relative to of the phone. This was in order to see which position of the phone relative to the magnet was the strongest magnetic field was being read. So this is the experiment. So the on-axis distance was a bar magnet to the magnetometer was found using the rule of several different magnetic field values, and these were the values. And so these values were like that pretty much. And now these are the off-axis fields that were found, and these are the values. So the observation was the magnetometer is distant from the magnet, and it detects almost negligible magnetic field along the x-axis. As the magnetometer gets closer to the magnet, the X component of the magnetic field becomes stronger, and the phone's orientation is crucial to prevent interference from the Earth's magnetic field, ensuring accurate readings of the bar magnet's magnetic field. These are my calculations to distance-dependent equation. So this was pretty much my y. My y was like negative 3.043x minus 14.363y, and n represented the slope, so the slope was negative 3.043. And to find k, we took the natural log of the y component pretty much, or of y, and which led me to get 4.42 times 10 to the negative 7th. And then using the Sarvat law to find mu, we set r to equal to 1 meter. Using the equation, we solved for mu, and mu became 2.21. Now this is my GlowScript code. So this is the first two, all the way till line 74, and this is from 76 on, and this is what the visualization looked like when you ran the code, and this was still the calculations I got. Now the discussion was, so the exact position of the magnetometer within the phone may not have been accurately located, leading to significant margin of error and affecting the distance measurements between the bar magnet and the magnetometer. If the magnetometer read reading didn't perfectly align with the Earth's magnetic field before starting the experiment, it would have distorted the off-axis measurements of the bar's magnetic field. And now this is the what if. So effect on not aligning with magnetic north. If the experiment had not been oriented to compensate for the magnetic north, and the meter stick was placed at the intermediate angle relative to Earth's magnetic field, the results would have likely been distorted. The off-axis influence of the Earth's magnetic field could have caused inaccuracies in the bar magnet's measurements, bar magnet's measured field. And the second one was the effect of using two identical magnets end to end. So if two identical magnets were placed end to end and the experiment was repeated, the magnetic field strength would likely increase. The measurements would show a stronger magnetic field, particularly along the combined length of the magnets, as the magnetic dipole would effectively double. Thank you. This is my presentation.